Alright students, so I just want to do a quick video on factoring quadratic expressions using the diamond game. And here we have an image of Minecraft. And I want to apologize again, hold on. I'm going to have some more background noise in this one. I am at another lacrosse practice. But anyway, here's a screenshot of Minecraft. I know that's a pig. I don't know what that is, maybe a dog. There's some TNT, I guess you can blow stuff up. This doesn't really have anything to do with factoring, but apparently you can find diamonds in Minecraft. At least that's what my kids tell me. Anyway, here we go. So here are the steps for factoring using the diamond game. And remember, this is standard form, and you want your exponents to go in decreasing order, and we're quadratic. A quad has a squared term, so quad is a square. So hold on a second, I have this backwards. So the third coefficient, this c, goes up top. The second coefficient, b for bottom, goes in the bottom. And then we're going to find the factors of c that sum to b for the sides. And then you're going to write it as two binomials. So let's look at an example. So this video is going to go through some special cases, and when you're using the diamond game, you really want this first coefficient, this a, to be 1. So we're going to learn some other ways to factor expressions with other terms that are not 1. So what I'm going to try and do is see if I can factor out this 6 to make this leading term a 1. So are all of these coefficients divisible by 6? Sure. They're divisible by 3. I remember my divisibility rules. 1 plus 2 is 3. 1 plus 8 is 9. 6 is 6. And they're all even, so they're definitely divisible by 6. So I'm going to factor out the 6. So the greatest common factor is 6. And then here, now I have a quadratic expression with the leading term here as 1. Now I can use my diamond game. So remember, c is going to go up top here. And the b, this -3, is going to go down here. Now, we talked about it in class. If and only if this b term is negative, then I know both of my factored terms here, my factored values here, are going to be negative. So I'm going to go ahead and put my negative signs in there. And the reason for that is when I have a negative here, I have a negative times a negative equal a positive, but I'm going to add them together to get a negative. So that's why. So what do I have? I have 2, so my factors of 2 are 2 and 1. Those are the only factors of 2. It's a prime number. So -2 minus -1 is -3. So I'm going to write it in factored form. So my two binomials here are going to be n minus 2 and n minus 1. Don't forget the 6. You don't want to just forget about that, because when I go back and check, I need to make sure that I get back to where I am. So I'm going to double distribute these two binomials, and I get n squared minus 2n minus 1n plus 2. Then I can combine like terms. -2n minus 1n is -3n. And then I can multiply through, distribute this 6, and this gets me back to where I was. So that's the first one. So let's take a look at one more. We'll take a look at this one over here on the right. So we have 6n squared plus 12n minus 144. And then we talked about it when c is negative. When c is negative, then you're going to want just one of these values to be negative. And take a look at this. Can I factor out this 6? Well, let's think about our divisibility rules again. 1 plus 2 is 3, so it's divisible by 3, and it's even, so it's divisible by 6. 1 plus 4 plus 4, that's 9. 144 is also even, so that's also divisible by 6, because 9 is divisible by 3, and it's also even. So they're all divisible by 6, so I'm going to factor the 6 out. That's going to leave me, again, apologize for the background noise. We'll wait for the train to go by. Okay, so I factored out the 6. That leaves me with this quadratic expression here with a leading term of 1. And so what I usually do when I see something like this, the first thing I'm going to do with a leading term that's not 1 is see if this goes evenly into the other coefficients. So that's the first thing. So to speed this up, check and see if that this coefficient here, the a, goes in evenly to this, so you can get it in this form where the leading term is 1. So that's a quick thing that you can just try. All right, so the c term, negative 24, goes up top, and then b for bottom, 2 is going to go here. Now I need to look for, remember, one term is going to be negative, the other is going to be positive, the factors of 24, right? So I have 24 and 1, 12 and 2, 8 and 3, 6 and 4. But here's the deal, because 1 is negative and 1 is positive, I really want to subtract these, right? So 24 minus 1 is 23, 12 minus 2 is 10, 8 minus 3 is 5, and 6 minus 4 is 2. But because you can subtract these in any order, you could actually say 1 minus 24, or 2 minus 12, or 3 minus 8, or 4 minus 6, depending on which one you make the negative and which one you make the positive. These could be positive or negative. So what you should do is go ahead and look and say, all right, what's my value here? It's a positive 2. All right, so positive 2, so that means I have to go 6 minus 4. If I were going to do 4 minus 6, then it would be a negative 2. So that's my solution. It's 6 minus 4. So 6 and negative 4. So I can write that in my two binomials. Again, don't forget this constant that you factored out to start with, 6. And it's n minus 4 and n plus 6. I can go ahead and check that by multiplying everything through again, and I'm good. I get back to where I started. So I just wanted to show these two examples because they kind of have a bunch of different intricacies. Like first you need to factor out this 6, this leading term, to get it, so you have a leading term of 1, and then you have the different signs that you have to deal with. So just be careful with that. Remember, if b is negative, this negative 18, then both have to be negative, and it's if and only if. Because if c is negative, then that means just one of these is going to be negative. Okay, so please let me know if you have any questions. Thanks. So factoring by grouping, we do this when we have a quadratic with a leading term that's not 1, because we can't do the diamond game. So let's take a look at how this works. So what factoring by grouping does is we basically divide it into two groups. So let's take a look. So the first thing we're going to do is find the product of a, c. So this number here is the coefficient a, and this number here, the negative 6, remember you're going to include the sign, and so we're going to multiply those two. We're going to find the product. So 4 times negative 6 equals negative 24. And then we're going to play the diamond game. We're going to use negative 24 in the top of the diamond game here, and we're going to find the factors of AC that add to B, which would be here at 5. So negative 24 and 5. So I'm just going to play the diamond game like I normally would, and this is going to tell us how we need to break up this term here, and we're going to divide this trinomial into two groups. So I know, remember, if I have a negative up here, then one of these is going to be negative and one is going to be positive, because I have two numbers when I multiply together that equal negative. So what are the factors of 24? Well, we have 24 and 1, 12 and 2, 8 and 3, 6 and 4. So if I'm going to subtract these, and I need to, or add a positive and a negative, I need to get to 5, so that's 8 and 3, right? 8 minus 3 is 5. So that's my factored group. So I'm going to split up B. So this coefficient here, I'm going to split this term into two terms. So I should really say split bx, because that's really what I'm dividing up. Excuse me. So negative 3x and positive 8x. And I'm going to go ahead and create a little barrier here. So I now have two binomials. right? I have this 4x squared minus 3x and plus 8x minus 6. Now you're probably asking, does it matter which one of these? It doesn't really matter. You're going to end up getting to the same solution. I like to actually put the negative over here. I don't really like to lead with a negative term. So if one of them is a negative, I would put it over here so it's not the leading term. Because leading terms that are negative numbers make it a little more difficult because you have to actually factor out the negative. So don't forget about that. So what I'm going to do is look for the greatest common factor from each group. So these are my two groups, my two binomials, and I'm going to find the greatest common factor from each of them. So what's the greatest common factor from 4x squared minus 3x? Well, I can get 1x, right? I can factor out an x because there's an x in both of these. This is x squared, this is x to the first. But then I can't really factor out anything from these two coefficients. So that's all I can factor out from this is an x. And then this one, these are both even, and I can't factor anything else out, so I'm going to factor out a positive 2. So x times 4x minus 3 plus 2 times 4x minus 3. Now, you know you did this right if these two binomials now are the same. Because what I'm going to do is I'm basically just going to factor that binomial out. Because what I do is I'm going to just combine these two GCFs. So x plus 2, that's going to create my new binomial. And really what I'm doing is I'm just factoring out this term from both of these. So that leaves me with x plus 2 remaining, and I've factored out this 4x minus 3. Because I'm multiplying these two here, the 4x minus 3 I'm just factoring out. So it leaves me with x plus 2 times 4x minus 3. Now I can go ahead and check it by double distributing, and I get 4x squared plus 8x minus 3x minus 6, combined like terms. Bingo, I did it right. Now if I asked you to solve it and not leave it in factored form, I would just go ahead and set that equal to 0 and then solve each of them. So x plus 2 equals 0, subtract 2 from both sides, x equals negative 2 is one possibility, and then I have 4x minus 3 equals 0, add 3 to both sides, divide by 4, so x equals 3/4. So there's my solution set, negative 2 and 3/4. So I hope this helps, and please let me know if you have any questions at all. Thanks.